So please go ahead and ask yourself what are the takeaways and what are the things that you learned here. And then probably more important is what is not clear to you and how can you get a better understanding or develop a better understanding of that. I encourage you to really write that out, because that is already enough to understand what you need to do sometimes. And then I want to go ahead and check these boxes off with you, but not without talking about the importance of each of these boxes. So first of all, the moment of inertia is a resistance to bending. Some in physics is called angular acceleration, right? The resistance to angular acceleration. But really for us, that means it's a resistance to bending, right? So to bending. And hopefully from my introduction, this is clear to you and you can actually check this off. You, of course, still remember how to calculate the centroid location. You can still do that. And you can also now calculate the moment of inertia for individual geometric simple shapes. And again, this is what we were talking about in the table. And we called that I bar x prime and y bar x y prime. So that I can check off as well, because that was the initial portion of the lecture. And then we, of course, calculated actually the moment of inertia for composite shapes. So the composite shapes is really everything we have done in the examples that I showed you. But how did you do that? You did that by applying the parallel axis theorem. So you find this in the lecture portion. So lecture, that was the last part of the lecture. And then the calculation of composite shapes was the examples, right? And that is really what you need to be able to do. And I think you can check that off. So with that said, let's move on to the homework and let's see what problems you can solve to practice your understanding of these concepts now. So here you see your upcoming homework, and let me give you hints so that solving these problems will be much easier for you. So for example, here we have the first problem in which you have effectively three shapes, a circle, and a rectangle. And please see or note that you have to calculate the centroid location first. Of course, this shape is symmetric about the vertical axis, but it's not symmetric about the horizontal axis. Unless your D is equal to your C, then you are very lucky. All right, but if that's not the case, then you have to calculate y bar first. And to do that, please don't worry about the fact that you have a little bit of overlap of the circle here and the rectangle and the circle here and the rectangle. In fact, just calculate them as individual. So here's a circle, here's a circle, and then you also just have the overlap of the rectangle here. I'm exaggerating here a little bit, but please do not start to subtract these from each other. That's beyond the concept that we're talking about here. And it's not conducive towards your learning experience. So we want you to understand the moment of inertia. We don't want you to do unnecessary math here. So that, I think, should give you enough hints for this problem. For this angle here, very straightforward, very simple shapes. You can break it down in different ways. But again, you have to probably calculate the centroid location first, which of course is already done for you here in a sense. But you need that to then calculate the moment of inertia of this shape. And you need to do it about the x and the y axis. And hopefully that will help you to develop a better understanding as well. Now let's take a look at this problem here. So here I suggest that you actually start thinking differently. After you calculate y bar, you of course know where x bar is because it's just in the middle, like C and C. It's symmetric here about the vertical axis. But all you have to do here is actually find y bar first, and then the think different part should kick in. I recommend that you actually look at this as a big rectangle, and then you subtract a triangle and you subtract this rectangle, because notice that this here is a hole in the shape, right? And so I want you to use this problem to actually practice the summation formula by subtracting. Remember that summation can also be subtracting or adding negative parts, and so just try to subtract this triangle, and this rectangle. And I think that will give you another powerful tool to be fast in engineering and of course in your exam. Then we have this problem here on the bottom. You have seen this before. It's actually part of the example problems that you were supposed to solve on your own. And if you have done that, then you have done half the work already, because you need the centroid location first, and then you find the moment of inertia. Once again, it's probably easier to subtract the circle. In fact, you have to subtract the circle because this is a negative area, and here you can probably subtract the triangle. Here, this I would not do subtractive. I would add this because it's very difficult to subtract everything here to the left of the circle. It's easier to use the semicircle here for your calculation. So I think that deciphers the problems on this page. Let me move on to the last page. So here you see very common structures. Here an I-beam, this should be pretty much a walk in the park after what we talked about here in this class or in this video lectures. So simple shapes, and you know that it's doubly symmetric, so therefore you know exactly where the centroid location is. Notice here that the centroid location is actually outside of the C channel, and that is confusing sometimes to students, but you can still calculate it as you usually do. So find your y prime and x prime axis, and then you have literally only 3 areas to deal with to find the distance to here. Notice that the thickness of the metal is identical everywhere, and I think this problem should not cause a lot of trouble to you, especially if you solved all the problems before. And with that said, I wish you good luck with your homework, and I hope we learned something new about mechanics that interests you and will help you in the future. And I will see you soon. Good luck.